area and volume scale factor. This is a very easy example of linear scale factor which has the symbol K. I want to find the length GH. Yeah. So my two triangles similar. I can see that I've multiplied by 2 to get to 24. I've multiplied by 2 to get to 36. So all I need to do here is multiply by 2. So 14 times 2, 28. But of course, it's not always that easy. In this one, it's a little bit harder to see, so I'm going to set up my K scale factor. So 2.4 corresponds to 1.8. So I'm going to write K equals 2.4 over 1.8. Now I can work with that fraction if I want to, or I can simplify that. So I'm going to simplify that to 4 over 3. So now that I have K, I need to find this length here. So it's also a length, so I just need to work with K. So I'll set up two equivalent fractions. 4 over 3 equals 3.6 over x. So I've put the 3.6 in the numerator because my 2.4 from this same triangle went in the numerator up here. So from the same triangle, I both put in the numerator. Now I just cross multiply. So I have 4 times x equals 3.6 times 3. Divide that by 4 on both sides. And that will give me 10.8 divided by 4. So x will equal 2.7, which is answer D. This is another scale factor. I've just put the two triangles one inside the other. So I might draw them separately. This is my large one. So this is 24. And this is 9 plus 27, so 36. In the question, I want to find the length DE. So that's there, that's my littler triangle. This length is 27. That's what I want to find out. So again, I'm just using K, scale factor, length to length. So I'm going to write my equivalent sides, which are 36 over 27. I'm going to simplify that. 9 goes into that 3 times, 9 goes into that 4 times. So now that I have K and I want to find a length, so I'm just going to use K, I just set up two equivalent fractions. 3 over 4 equals x over 24. And again, the 27 and the x both went in the numerator. Cross multiply, 3 times 24 equals 4x. 72 equals 4x, divide by 4 on both sides, and x equals 18. Next one, we have a swimmer. And we want to find out the depth at the water 8 meters from the shallow end. So we want to find this point here, TU. So what I'm going to do first is I'm going to make two similar triangles. Try and draw that a bit straighter, like that. So I have this one here. I'm going to draw here. And I know that's 8. And I don't know that distance. I'm not sure what that is. And then I've got the larger triangle, which is this one here. To get this distance here, this is 1.8 and this is 1. So I'm just going to do 1.8 minus 1, 0.8. And I know the distance along the top is 11 meters. So again, I'm just working with K, linear scale factor. So I'm going to set up two equivalent fractions. So 8 over 11 will equal x over 0.8. I'm going to cross multiply that. 11x equals 6.4. Divide by 11 on both sides. And x equals 0.58. That's not my whole answer. Here was 1 metre in purple. So this distance here is 1 metre in purple too. So to find my distance TU, I have to do 1 plus 0.58 to get 1.58 metres. And there's my answer in D. All right, this time we have side length of cube A is 1.5 times the side of B. Okay, so I could call this one and this 1.5. Or I don't want to work with decimals, so I might call this 2 and this 3. Because 2 times 1.5 is 3. So side length A is 1.5 times bigger than side length of cube B. So that's a side length, so that's K. So I'm going to write K equals 2 over 3. I want to find the surface area. So this time I need to find K squared. I can't find an unknown surface area unless I know K squared. So I just have to square my K. 2 squared over 3 squared. I always leave it as a fraction. So then I can use my cross multiplying, set up 2 equivalent fractions and cross multiply. I do it the same way the whole time, so then it's easier. So this is K squared. This is my scale factor for area. Now that I have that, I can find the unknown area by setting up 2 equivalent fractions. So my K squared is 4 over 9. My surface area of B is 256. Now B was this one 2, and I put the 2 in the numerator, so I have to put the area of this one in the numerator. And my unknown area is cube A. 3 went in the denominator, the unknown goes in the denominator. Now I cross multiply. 4x equals 9 times 256. Divide by 4 on both sides. And x equals 576. So answer D. This one, the area of one face of the larger cube is 12 centimetres squared. So I've coloured that in there. Just one face is 12 centimetres squared. And the total surface area of this cube is 78 centimetres squared. The smaller cube, just one face, this one that I've coloured in, is 6 centimetres squared. I want to find the total surface area of this one. Okay, so this one I have K squared because I have an area. So K squared equals 12 over 6 or 2 over 1. Remember, I always leave it as a fraction, so then I can set up 2 equivalent fractions and cross multiply. I want to find an area. I've already got K squared. I need K squared, so I don't need to change it. I just need to set up my 2 fractions. 2, my 12 went in the denominator, so my 78 goes in the numerator, and 78 goes in the numerator. Then I just cross multiply. So I have 2x equals 78. Divide by 2 on both sides. X equals 39 centimetres squared. Next one, a cafe sells 2 sizes of cupcakes with a similar shape. The large cupcake is 6 centimetres wide and the smaller one is 4 centimetres wide. The price of a cupcake is proportional to its volume. A large cupcake costs $5.40. What will the small one cost? So first of all, I have K because I have a width. So I have K equals 4 over 6. And I might just simplify that 2 over 3. I want volume, so I need K cubed. So I just need to cube that. So K cubed equals 8 over 27. Now that I've got K cubed, I can find an unknown volume by setting up my 2 equivalent fractions. So 8 over 27 equals, it doesn't matter that it's a price, it doesn't have to be centimetres cubed. So my large cupcake is 540 and I put my large width in the denominator. So I have to put my $5.40 in my denominator and my unknown price for the small one in the top. I cross multiply. 8 times 540 equals 27x. Divide by 27 on both sides. And x will equal $1.60A. Let's go to this one. I have two bowls. One has a total surface area of 1,500 centimeters squared, and the other one is squared. So I have total surface area. So I have k squared, and it is 1,500 to 3,375. I don't want to work with those numbers, so I'll put that in my CAS to simplify it for me, and that is 4/9. K squared is 4/9. I want to find the capacity. I have the capacity of the smaller ball. I want to find the capacity of the larger ball. So capacity is volume. So I need k cubed, but I've got k squared at the moment. So to go from k squared to k cubed, I just need to square root to get back to k, and then cube it to get to k cubed. So k squared, 4/9. So to get k cubed, I need to square that and then cube it. I need to square 9 and then cube it. I always leave them separate so I can set up my cross multiplying equivalent fractions later. Square root of 4 is 2, 2 cubed is 8. Square root of 9 is 3, 3 cubed is 27. Even if it's not whole numbers and you've got some ugly decimals, just work with 3 or 4 decimal places and it'll still work out fine, because in the exam or the question, they're only going to ask you to the nearest centimetre or 1 or 2 decimal places. So if you work with a few more decimal places, it doesn't matter if they're ugly numbers. All right, so I've got k cubed now, 8/27. Now that I've got k cubed, I can find an unknown capacity. I want to find the capacity of the larger bowl. My larger bowl I put in my denominator. I put my x in my denominator. The volume of my smaller bowl was 1.25 litres. So I just cross multiply. 8 times x equals 1.25 times 27. Divide by 8 on both sides. X equals 4.2 litres. This next one is just the same. I have two total surface areas and I want to find a volume. So again, it's k squared going to k cubed. So I'm going to find my k squared. Doesn't matter which order I put it in. I'm going to put 200 over 288. Now I could work with those numbers if I wanted to, or I might ask my calculator to simplify it for me. 25 over 36. Now I've got k squared. I want to find a volume, so I need k cubed. So to get to k cubed, I have to square that and then cube it. So I have to square 25 and then cube it. I have to square 36 and then cube it. Square root of 25 is 5, 5 cubed, 125. Square root of 36 is 6, 6 cubed is 216. Now that I've got k cubed, I can find an unknown volume by setting up my two equivalent fractions. 125 over 216 equals 1000 over x, or x over 1000. I'll just check. I put 200 in the numerator, so from the same shape, the 1000 has to go in the numerator over x. Cross multiply, 125x equals 216 times 1000, which is 216,000. Divide by 125 both sides, and x equals 1,728 centimeters cubed. This one, find the ratio of the volume of the blue portion to the volume of the pink portion. I'm just looking at volume. What have I got? I've got length. I've got K. And I've got 1h to 3h. So 1 to 3. I want volume, so I have to cube that. 1 cubed over 3 cubed. K cubed equals 1 over 27. So the 1 is the volume of the blue section. And the 27 is volume of entire shape. But I want to find the blue portion to the pink portion. So the pink portion only is the whole amount, 27, minus the blue portion, 26. So the volume of the blue portion is 1 to the pink portion, 26. I haven't done an example of volume going back to linear or volume going back to area, but remember, you work out, have I got k, have I got k squared, have I got k cubed, work out which one you've got, and then work out what your unknown is. If you've got k cubed and you want to go find an area, you take the cube root and then square it. If you've got a volume and you want to find a length, you just take the cube root to get back to k. And if you always set them up as equivalent fractions, two fractions, and cross multiply, can't go wrong.